Today we're going to look at shapes of graphs and also the graph's domain and range. So the first type of graph that we're going to look at is like this. Slope and y-intercept. Let's try graphing the first one, 9 minus 3/4 x. So this one starts at 9. Actually, I'm going to move this down before I graph it. Okay, so this one starts at 9, and the slope is negative 3/4. So what that means is we're going to go down 3, 1, 2, 3, over 4. 1, 2, 3, 4. Let's do it one more time. Down 3 over 4. And then we're going to draw an arrow with our line here. And this represents our line, 9 minus 3/4 x. Let's try the next one. The y-intercept is 5, or negative 5. And our slope is positive 2. So we're going to go up 2 over 1. I'll do it a few times. And then again, we'll take our line tool and draw our line. Let's talk about domain and range for these. Domain is all possible x values. And since these arrows go on forever, all real numbers are going to be hit. So all real numbers for possible x values, because any number will have an answer on the graph here. And the range, if you take a look at the ranges, the y values, and again, since the arrow keeps going up and down, the range here is all real numbers. And that's actually true for both of these graphs, all real numbers for domain and range. So every value of x will have a value of y. Okay, let's take a look at the next two. Y equals 4, so that's this guy. Slope is 0, so it's flat. And the next one, x is negative 2, so we find where x is negative 2. Okay, let's talk about domain and range here. So here the domain is all possible, so all real numbers. Every x value has an answer, but here the range is just one answer. The range here is 4. Y equals 4. Here the domain is just x equals negative 2. That's the only value of x we have, but the range here is all real numbers. What is the shape of all these graphs? Well, these are all straight lines, and so we say all of these are linear. Let's look at another type of graph, type 2. All right, let's sketch the graph of y equals x squared. What shape is the graph? Let's plug in x squared. Let's plug in when x is negative 2. So y equals negative 2. Let's square that, and that would be 4. How about negative 1 squared? That's 1. 0 squared is 0. And if we plug in a 1 squared, that's 1. And a 2 squared is 4. And so if we were to graph this, we have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And if we graph it, it's a parabola. That looks like this. Domain. So again, these arrows keep going for all values of x. We say all real numbers. But here the range, if you take a look, there's some y values that are not ever met, and that would be these y values below 0. There's nothing right here for the y values below 0. So we say y is greater than or equal to 0. The vertex is where it changes direction, and here it's at the origin. At 0, 0 is where it changes direction. It says using your graphing calculator, graph the following, place the vertex in the right spot, and then sketch your graph. State each graph's domain and range. All right, so let's graph. If I open a graph page here. Let's do that again. Okay, so here is the next graph. It's x squared, but this time it's plus 4. And if you take a look, that one looks like it moves up 4 here. 1, 2, 3, 4. And then we can sketch that graph. How about the next one, x squared minus 3? So on our graph, I'm just going to hit tab. I'm going to go up. And then here I'll go minus 3 and hit enter to graph that. And that one goes down 3. So let's graph that. Down 3. Sketch that. All right, so domain, again, all real numbers right here because the arrows keep going across. So we say all real numbers. The range, though, look at the y values here. They start at 4 and they go above, but there's nothing below 4. So y is greater than or equal to 4. Let's look at the domain and range of this one. Again, all real values of x, all real numbers, because the graph keeps going. But the range, here the range changes. The lowest value is -3 and above. So y is greater than or equal to -3. Okay, oh, let's take a look at these. So there's more to graph right here, and we'll talk about domain and range. So let's graph in parentheses. So I hit tab, and I'll get back to this graph. Oops, equals. Okay, so I want in parentheses x plus 3. And then we'll square this. Okay, so this one, think about the vertex that was at 0, 0. This one shifts to the left 3. So let's go there, left 3. Domain, all real numbers. The range, though, again, 0 is the lowest value I see for y, so y is greater than or equal to 0. Let's try the next one, x minus 3. Make a prediction. What do you think is going to happen to the graph? So let's hit tab and go up. Okay, so minus 3. This one goes to the right 3. So let's graph that. 1, 2, 3. We'll sketch our graph here. And again, it's all real numbers. The range is like the other one. Y is greater than or equal to 0. Okay, last two. What about if we have negative x squared? Let's take a look at that. So let's graph negative x squared. And that flips it upside down. So that's going to change our range here. Oops. Domain, all real numbers. The arrows keep going. But the range, y is less than or equal to 0. And let's try this one, negative 4x squared. And that just made it skinnier, looks like. So if we were to graph that skinnier, even though it's skinnier, it will still keep going. So the domain is still all real numbers. But the range, y is less than or equal to 0. By looking at the equation, how do you know if a graph is linear? So we knew it was linear if we just had an x by itself. So here these are linear, and they just had an x or a y by themselves. So if it's just x here, it's linear. So you can think y equals mx plus b. Quadratic is this other shape. It's called a parabola. It's a U-shaped graph. Let me find some. And these are all called parabolas right here. And if you notice, they all had an x squared in them. So again, this is y equals mx plus b. It's just the x here, not a squared. It's linear. But if it's quadratic, you might have an x squared. You will have an x squared. And so we'll take a look today at practicing domain and range and also these graphs.